So let us solve this question. This is from your kinetic theory chapter. Here the cylinder of a fixed capacity of 44.8 liter contains helium gas, standard temperature and pressure. What is the amount of heat needed to raise the temperature of the gas in the cylinder by 15 degree? Very important question type. This type of question comes in the exam in the entrances also. So let us solve it. Okay. So here the container is a fixed container. That means the volume will not increase when we will increase the heat. Okay, it's a fixed capacity, the capacity can't be increased. So like here the volume we have to consider is a constant one. So volume will be constant, right? And in this container the amount of helium gas is there 44.8 liter. So we'll use the mole concept here. So 44.8 liter means it's 2 moles, right? 1 mole is you know that 1 mole is your 22.4 liter. So here 44.8 means it's 2 mole. Number of mole is 2. Let's say mu we are representing. So number of 2 moles uh, in terms of moles, 2 moles helium gas is there inside this container. So now what else is given? We have to raise the temperature 15 degree. How much heat is required? This is the question, right? So we have to supply the heat to this container. Its volume will not increase, but the temperature will increase 15 degrees centigrade. So volume will not increase. That means we can use the concept of CV, your specific heat capacity for constant volume, right? Because your volume will not increase, so we can write CV. And you know that CV is 1 upon mu in mole delta Q by delta T. This is what the formula for CV, specific heat capacity, that is the amount of heat required to supply or required to raise unit temperature of unit mass. This is what the definition of specific heat capacity. So here what are the things given? Here we have to increase temperature 15 degree means dt is given, right? So what we have to find out? We have to find out what is the amount of heat that is required to increase this temperature. That means we have to find out dq. So if I'll write this, so we can write dq equal to mu cv dt. So you see all the uh, parameters are given here. Mu we got 2 mole, dt is 15 degree, right? Because dt is just change, so we can use 15 directly. You can convert to Kelvin, it will be 15 only. It's a change only. So cv, the only quantity we are not known yet, that is cv. So cv I have already discussed, or I can make a short video also about cv. So here cv is not given, but indirectly it's given. How? Because it is given that it's a helium gas, and helium is a monoatomic gas basically. So helium is a monoatomic gas. So helium is a monoatomic gas, it's a noble gas, so monoatomic. So monoatomic gas will have the degrees of freedom 3, so it will have the energy 3 by 2 kt, right? 3 by 2 kt. And you can use the concept of your cv, that is equal to du by dt. in this concept you can use, this is your internal energy. So you can use the formula and you can find out that cv, or you can find out here only, let's say for 1 mole, right? For 1 mole, what is the cv? Du by dt, here 3 by 2, if you multiply number of mole is 1, so kb na will be r, and d by dt of t derivative is differentiation is 1, so it will be basically 3 by 2 r. cv will be 3 by 2 r, right? If you are not getting that how I have done kb, so just I multiplied 1 na here and divided na, means we have taken not divided na, we have just taken for 1 mole. So 1 mole means cv for 1 mole will be it will be 3 by 2 kb into na. So kb into Avogadro's number, Boltzmann constant into Avogadro's number, it's a gas constant r, right? This is the relationship, so you should know this. I hope you know. If you are not if you do not know, I will discuss again in these things, this concept. So all these things now we have, just will multiply it. Mu is 2, okay, mu is 2, cv is our 3 by 2 r is given here 8.31 joule mole inverse k inverse, this is inverse, okay. So this is 8.31 and dt is 15. So just to multiply all these numbers and you should get it around, this number should be, you check it, that number should be approx 374 joule. If you multiply all this one will cancelled out, so it should come approx 374 joule. So this much of heat should be supplied to the container, whose volume we cannot change, or it is a fixed volume of kind, and the container is containing 44.8 liter of helium, and we should provide 374 joule to raise 15 degrees centigrade. The temperature should increase 15 degrees centigrade. So this is the answer. Thank you. We will discuss some more concepts in the next video.